So what we're going to do is the derivation for parallel and perpendicular polarization, which is very, very important, 7 marks question. So what I'm going to do right now is I'm going to show you the question. So this is the 7 marks question which will be asked in the exam. So it says derive an expression for, you have to check always, this is reflection coefficient. When a wave is incident, so when a wave is incident on what kind of dielectric, and how is it incident obliquely with what kind of polarization? Parallel polarization. So the difference in the question is either this will be parallel or it will be perpendicular. And you may have a question where they will ask you reflection coefficient, or they might ask you transmission coefficient. So let's see how it is done. So first and foremost, what are they doing here is the reflection of a plane wave. So a wave is getting reflected. So there is a reflection of the plane wave by what? By a perfect dielectric. And how is that wave incident? It has some oblique incidence, that means with some angle. And what kind of polarization we are looking at? Parallel polarization. So repeating once again, it is the reflection of a plane wave by a perfect dielectric. So when we say perfect dielectric, we are looking at the medium. What kind of incidence? Oblique incidence with parallel polarization. So what I'm going to do right now is that there are two mediums. This is medium 1 and this is medium 2. So you can also draw the diagram, medium 1 and medium 2. Medium 1 will have some constant mu1 epsilon 1 and medium 2 will have a constant mu2 epsilon 2, right? So two mediums are there. This is the interface of the medium. That means the boundary. Interface meaning the boundary of that medium which I have drawn. This straight line here is nothing but a normal, right? It is just a normal that is drawn perpendicular to that boundary. Now what we are doing is we are going to draw the ray. So let's say that there is a ray which is coming and striking here. So this is the ray. So you can also mark this as the ray. And it is getting reflected to this medium. That means same medium, it is getting reflected back. And they are perfectly the same. So when you draw, you have to draw it same. So this is same. Let's say the angle of incidence, I'm going to call it as theta 1. Okay, and that means this is also theta 1 because I'm considering perfect reflection here. Okay, so this is one arrow in the downward direction. Here you see it, and this is the reflected arrow. And some part of it is getting refracted. So I'm going to draw it into this medium. And this angle, I'm going to call it as theta r, you can call it as theta t, you can call it as, this is theta 2 for me. So I'm just going to talk of theta 1 and theta 2. So this is the incident, angle of incidence. This is the reflected one. This is the refracted one. Very simple derivation it is. It's not very complicated. You just have to know what you have to draw here. So first thing is, this is the first part of the diagram. Then what you have to do is take some points here. So I'm taking 1 point here. I'm taking 1 point here. And I'm going to take 1 point here. Okay. Now, how to look at this? Now, this is actually not the point. Actually, it means outward. This dot means, if you remember, I must have told you, dot means outward and cross means inwards. So what is happening is this wave is propagating in this direction. Okay. So how is this? What kind of incidence is a parallel polarization? The plane is actually parallel to this. The plane is actually parallel to this. That means you have to imagine that if this is the surface and this is the wave is coming like this, then this particular ray is parallel to this plane. You know, it is parallel to the plane. That is what is the meaning of it actually. Well, right now you just remember that perpendicular to this point will be EI. So you'll have two components, right? So EI you have to draw like this. And HI is coming out. That's why you just have to write HI. That means HI is coming out and this wave is going in this arrow direction. This wave is going in this arrow direction. That's what you have to know. Okay. Similarly, out here, this is ER, perpendicular. You know that the direction of propagation, electric field and the magnetic field will be mutually perpendicular. So if this is the direction of propagation, then perpendicular you have to draw ER, and you can, over here, you just write HR. Okay. Similarly, this is the direction of propagation. Perpendicular to this, you write refracted. So you can either write ER or you can write ET, because reflection is also R. So you take this as ET. This much you have to draw and keep first. Okay, so I hope you understood. EI is perpendicular to the direction of propagation. ER you have to draw perpendicular to this line. ET you have to draw perpendicular to this line. This much should be done. Write HI here, HR here, and write HT here. Okay. Now the third step of this, what you have to do is draw an angle here. If you can see this, this is like a normal to this. So draw an angle here and understand that this theta1 here and this angle here will remain the same. That means if I draw the line from here, this theta1 and this theta1 will be same. Just draw, you have to draw and keep. And here also you have to remember that this theta2 and this theta2 will be same. So this is the third part and the diagram is complete. So this diagram will itself give you 2 marks. 2 marks is for the diagram. So you have drawn medium 1, medium 2, you have drawn a boundary, you have drawn a normal, you have drawn incidence, reflected and refracted. So what is parallel polarization? Basically the electric field vector. The meaning of this is that the electric field vector is parallel. If this is your plane, then it is parallel to that plane. That is the meaning of it. It is actually parallel to the plane of incidence or perpendicular to the boundary. It will be perpendicular to the boundary, but parallel to the electric field. So like if this is a plane and I say something is perpendicular, then I have to show it like this, right? If this is a plane and if it is parallel, I have to show it like this. It is parallel to that plane. So you don't worry about that right now. You just remember how you have to draw EI, ER and ET. So that is why parallel polarization. Actually the electric field vector. So I'm just writing one statement. So this is the first step of the derivation, that you will draw the diagram. In the second step of the derivation, what you do is you write what is parallel polarization. That is, if the electric field, so they will understand that you are aware of it. So you write that if the electric field vector is parallel, it is parallel to the plane of incidence. The electric field vector is parallel to the plane of incidence, or perpendicular, it is parallel to the plane of incidence, or it is perpendicular to the boundary. So this is very, very important. This is one line we have to write. That's all. No other statement will come in the entire derivation. To the boundary, then it is called parallel polarization. So this statement should be written. This is called as parallel polarization. Okay, so what are we saying? We are saying that that electric field vector has to be parallel to the plane of incidence. So wherever the plane of incidence is, if the electric field vector is parallel to it, then we call it as parallel polarization. Or if the electric field vector is perpendicular to the boundary, then we call it as parallel polarization. So this statement has to be written. Now we are starting the derivation now. So I hope you are all ready. You have your notebooks. It's going to the third point. And that's where the derivation begins. So now what is the derivation? I'm going to start off. From continuity of tangential components of electric field, of electric field. So you can say from continuity equation, or you can say continuity of tangential components of electric field, or you can say that, we know that. And if you don't get anything, then just write we know that. Okay. Then write here EI cos theta 1 minus ER cos theta 1 is equal to ET cos theta 2. You don't have to by heart this. Look at the diagram if you forget. You have to understand that which component is this. This is the cos component. I hope everyone is aware now. This is the cos component, right? Cos component is going like this. This is the also the cos component of the R1. So one is going which direction? Right. The other is going left. Where is this fellow going? This is also going which side? Right. So that means these two vectors will get added and this one will be subtracted. That is what we have written. Is that clear? These two vectors will be added. So EI plus this ET. So this is EI cos theta 1, right? What is this line? This is ER cos theta 1. What is this line? This is ET cos theta 2. So two are going in the right direction. One is going in the left direction. So that is what we have done. We are just saying EI cos theta 1 plus ET cos theta 2 is equal to ER cos theta 1. So two are going right, one is going left. So the same thing, I have just rearranged it here. Okay. So two are going and I have just written it in that manner. Now what we are going to do is we are going to take the ratio from this equation. We will write ET upon EI from this equation. So it will come, if you solve it, check and see, it will come 1 minus ER upon EI into cos theta 1 upon cos theta 2. So from the above, I'm getting this. I've rearranged and I'm getting this particular thing. Now point number 4, which is the most important part of this derivation. What we have to do is we have to write ER square. That means this is actually from the incident, transmitted, reflected equation, but this we have to learn. This is ER square upon EI square. We have to start with, we know that only. So this you have to learn by heart. ER square by EI square is equal to 1 minus root of epsilon 2 upon root of epsilon 1. ET square, you can actually derive it also, but it takes time. So ET square upon EI square cos theta 2 upon cos theta 1. This is something that I would want you to learn because for both the derivations, you need this. This is very, very important. You have to know this. There's no chance. Without this, we can't do any of the derivations. So this is something that we have to know because we want to find this one. Now, what we are going to do, we are not doing something great. We already know what is ET upon EI. We are going to substitute that in this ET upon EI. This ET upon EI here, you can see is taking square. So we are going to take this ET upon EI, this expression, and put it inside this. So if you want, I can call this 1. I can call this 2. What we are doing is we are going to put 1 in 2. We are going to put this first equation in the second equation. So let's put that, the first equation in the second equation. So what will happen? So which point we are at? 4th. The 5th point will be ER square upon EI square is equal to 1 minus root of epsilon 2 upon root of epsilon 1. What will come inside this? 1 minus ER upon EI. I will put it as whole square. Cos square theta 1 upon cos square theta 1. Sorry. This is 2. Into cos theta 2 upon cos theta 1. So I hope you understood what we are doing. You please do it with me. This ET upon EI, whatever is this expression, I have just substituted. So this is square, right? So this whole thing square cos theta 1 square upon cos theta 2 square will come here in that place. So if I do that, it will look like this. Now it's very simple. Now all you have to do is, what you have to do? Cancel. This will get one cancelled. This also one will get cancelled. Right? Now what is left? If I do that, then what is left? I'm going to rearrange something here. You can open the bracket also. And this I'm going to write it as a plus b into a minus b. In other words, what I'm going to do? I'm going to take all these terms on this side. I'm going to take all these terms on this side and keep this one here. Okay. So you can solve and see. You can take one term on the other side. It's going to look like root of, or you can take this one on the other side. Okay, whichever way you want to do it. Epsilon 2 upon root of epsilon 1, bracket 1 minus ER upon EI, the whole square, cos theta 1 upon cos theta 2. So I kept this whole expression here as it is equal to, this will become, after taking it on the other side, that means I just took this one on the other side, it will become 1 plus ER upon EI into 1 minus ER upon EI. So this is, I think, more simpler instead of taking that term. So I kept this much terms as it is. And I have taken this one here. So that, and then I have taken a plus b into a minus b. If I do that, then what is going to happen? This one term and this one term I can cancel, right? One term will be left here. So finally, what I'm going to get. So if you're doing it with me, then I'm going to simplify it. So this is epsilon 2 upon epsilon 1, bracket 1 minus ER upon EI, cos theta 1 upon cos theta 2 is equal to 1 plus ER upon EI. It will look like this. Are you doing it with me, anyone? So then I will also know that whether I should go slow, fast.
Yes, ma'am.
Okay, so I'm continuing. So if you're doing this, you get at point number 5, we are at this expression. Now we have to take the LCM. You have to take the LCM of this term. In other words, open the bracket. Forget about LCM. Open the bracket. So take this inside. So open this bracket. So if you open the bracket, what will happen? I'll just write that again here. Root of epsilon 2 upon epsilon 1, 1 minus ER upon EI, cos of theta 1 upon cos of theta 2 is equal to 1 plus ER upon EI. I'm just opening the bracket in front of you. What will happen? Root of epsilon 2 upon epsilon 1, cos theta 1 upon cos of theta 2, minus ER upon EI, root of epsilon 2 upon root of epsilon 1, cos theta 1 upon cos theta 2 is equal to 1 plus ER upon EI. Right? It will look like this. Now I'm taking the LCM of this. So what will I get? Root of epsilon 2 cos of theta 1 minus epsilon 1 cos of theta 2 upon root of epsilon 1 cos of theta 2 is equal to ER upon EI, root of So I've done the LCM on both sides. I've taken it on the other side. It will look something like this. This is something you have to solve now. Okay, so we are just adjusting over here and we are taking the LCM. What will happen? This 2 will get cancelled. This 2 will get cancelled. And now what expression we need, what is the question about, is to find ER upon EI. That is what is reflection coefficient. The question is find reflection coefficient. What is reflection coefficient? ER upon EI. So therefore, ER upon EI becomes root of epsilon 2 cos theta 1 minus root of epsilon 1 cos theta 2 upon root of epsilon 2 cos theta 1 plus root of epsilon 1 cos theta 2. It will look like this. You can call this as equation number 3. This is reflection coefficient. So at the end of this, you get 4 marks. You're almost there. You get 4 marks for reaching till here, if it's a 7 marks question. Because then if they ask you to find transmission coefficient, then you have to, otherwise it's one straightforward 7 marks. So now from Snell's law is the basic law of physics, which says sine of theta 1, sine I upon sine R, isn't it? So sine I upon sine R is, here it is, sine I is 1 and R is 2, is given by root of epsilon 2 upon root of epsilon 1. This is the next to remember box. This is your equation number 4. Now I'm going to substitute 4 in 3. Wherever there is sine theta, I can go and substitute there. Right? So let's see what I can do. Or I can just substitute for epsilon. Let's say, okay, let's do it like this. Take root of epsilon 2 is equal to, what will it be? If I want this one, then take this on the other side. It will become root of epsilon 1 sine theta 1 upon sine theta 2. Okay. So now this expression, wherever there is this term, I will go and substitute here. So wherever these terms are there, one place, second place, I'm going to substitute this root of epsilon 1 sine theta 1 upon sine theta 2. So if I do that, what will I get? I will get, this is equal to ER upon EI is equal to root of epsilon 2 sine theta 1 upon sine theta 2 cos theta 1 minus the root of epsilon 1 cos theta 2 upon root of epsilon 1 sine theta 1 upon sine theta 2 cos theta 1 plus root of epsilon 1 cos theta 2. Now I'm further solving it. Sine theta 1 cos theta 1 minus sine theta 2 cos theta 2 upon, so when I finish this, I want you to practice and then only go for the next derivation. So after this video, when I upload it, you do it once again and then you are done with this derivation. So it's a straight 7 marks. Now this is what sine A, right? So what I'm going to do here is, I'm just going to multiply 2 everywhere. This 2, 2, 2, 2. So this is something you have to remember. Now if I multiply 2 everywhere, this will become now 2 sine of 2 sine 2 theta 1 minus sine of 2 theta 2 upon, this is going to be sine of 2 theta 1 plus sine of 2 theta 2. So this is what I'm getting as ER upon EI, simplifying using Snell's law. Okay, so this is one way of writing it. And that was another way of writing it. That is ER upon EI. This is after Snell's law. Now, our ultimate goal is to find ET upon EI. What is our ultimate goal? ET upon EI. I'm going back to expression, the first expression. We have to find ET upon EI. And what is ET upon EI? 1 minus ER upon EI into this term. So you're going back to 1. So I'm going to write from 1. From 1. So what do I get from 1? I'll get ET upon EI is equal to 1 minus ER upon EI into cos theta 1 upon cos theta 2. So this is going to be 1 minus, what is ER upon EI? Just now I have written sine 2 theta 1 minus sine 2 theta 2 upon sine of 2 theta 1 plus sine of 2 theta 2 into cos theta 1 upon cos theta 2. So this is how it looks like, right? So this is the entire expression looks like this. Now, therefore, ET upon EI can be written as, we are taking the LCM. You can also take LCM and check. This will become 2 sine 2 theta 2 upon, it will be sine of 2 theta 1 plus sine of 2 theta 2 into cos theta 1 upon cos theta 2. This is 2 sine cos. This is 2 sine cos, which can be written as 4 sine 2 theta 2 cos theta 2 into cos theta 1 upon sine of 2 theta 1 plus sine of 2 theta 2 into cos of theta 2. So this term and this term gets cancelled. And the final answer for this derivation ET upon EI, which is transmission coefficient. This is called transmission coefficient. So finally, the transmission coefficient becomes 4 sine theta 2 cos theta 1 upon sine 2 theta 1 plus sine 2 theta 2. This is how the final expression will look. So I want all of you to go back, practice it, and then I will do the next derivation. Is that clear? So I am closing it now.